go. All right, so we did potassium hydroxide yesterday, ammonium acetate. You guys were doing that on your own. Again, write your charges first. All right, ammonium NH4 plus 1. Acetate, one of the formulas is C2H3O2. All right, we do our crisscross method. Cross them over, become subscripts. We get NH4 in parentheses, C2H3O2 also in parentheses, just like that. All right? All we did was just crisscross our charges over to be subscripts. Questions with that one? Is this really that bad, guys? It's awful? Just terrible? Yeah. Super, super difficult. All right? Now, it's easy when we're isolating them one by one. When things get mixed together like the end of next week, that's where it becomes challenging if you don't go through your process. Now, I will have a graphic organizer that will help you guys kind of think through the process of what you want to go through. We'll do a lot of practice with it, so don't freak out yet that, oh, it's going to get super hard. If you put the time and effort in and practice, it won't be bad. If you just think, oh, I got to do a few examples in class, I'll be fine for the test, it may not end well for you that way. All right, so we're going to skip over this right here. All right, that was homework from last night. We just did that. Here's what we're going to do today, guys. I'm going to pass out your sheet for this. We were doing the crisscross method with transition metals. All right. What do all transition metals have to have with them? Charge, right. But do we know the charge? No, because they what? They vary, right? So what do they have to have in the name? Okay, the other element is going to tell us what the charge is. That's what we're going to figure out today. But when we write the name out, and we noticed yesterday, if you don't remember, guys, look back, they have to have a Roman numeral. What does the Roman numeral tell us? The charge of the transition metal, guys. So when you see a Roman numeral in a name, it tells you the charge that's associated with that transition metal. All right? But what if you're given the formula and you have to write the name? Yesterday we were given names and writing the formula using the crisscross method. Super easy. Now we're going to flip it and have to go from the formula and figure out the name. It's a little bit more complex when you have transition metals. Type 1, where we know their charges, it's super easy. Right? We basically just look at their ions, we put their names together. Right? So like sodium ion and chloride, it's sodium chloride. Transition metals, though, we have to have that Roman numeral, so we have to then have the Roman numeral with it. We got to figure it out. So here we go. This is kind of what we're going to do, guys. This looks more complex than it actually is. So if you are one who doesn't like equations, breathe for me. All right, don't freak out. By the end of this sheet and by test day, hopefully you'll be able to just kind of picture in your mind and look at your two pieces that you have to then not have to go through the whole math piece. All right, that's kind of what we want to work to. But if you don't get there and you got to do the math, you feel comfortable with it, go ahead and do it because it'll get you the right answer every single time. So our first one, guys, what we're going to do is we're going to count the number of cations. We're going to figure out the charge of the cation. That's what we're always looking for. The anion is going to be the key player for us here. We know the charge of the anion every single time. It's the cation we don't know because cations are what? They are positive, right? And type 2 elements, metals, are always cations because they lose their electrons. So we're always looking for our transition metal charge. So the first thing we want to do, we kind of started doing it yesterday. I believe, if I remember correctly, we did. You want to start getting into this habit, though, guys, of splitting up your compound, drawing a line where your cation ends and your anion begins. And what's the key that pretty much always shows us this? Where does the cation end and the anion begin? What are we looking for? Second capital letter. There's going to be one exception to that, and that's ammonium, because it's a positive polyatomic ion. That's the one exception. Pretty much, guys, the second capital letter is going to kind of tell us where we're going to split it up. So this first one, MnO, we're going to draw our line right before the O. Everything before that line is your cation. Everything after it is your anion. So if you have more than one element listed there after the line, that means you have a polyatomic ion. All right, we'll see some examples like that. So here we go. How many cations? What is my cation? Manganese. What's my anion? Oxygen. Okay, so how many manganese ions or atoms do I have in this formula? 1, right? Do I know its charge? No, because it's a Transition metal. So we're always looking for the charge of the cation because it's a transition metal here. How many anions do I have? I've got one. What's the charge on oxygen, guys, that it normally forms? -2. Where do we get that charge from? Yeah, guys, our reference packets. We've already written that in there. We've discussed it. We know the charge. All right, so it's a -2. So if you don't have your reference packets out, get them out. They're going to be helpful for you today and every day when we name. All right, so that's the information we have. Now we're going to build an equation that will allow us to solve for x. So when we take our cation and our anion together in a formula, what do they always have to equal? 0, right? Because we're trying to neutralize the charges and cancel them out. So everything we have, we're going to set it equal to 0. So guys, what we're going to do is we're going to take the number of our cations. That's 1. We're going to multiply it by the charge, which is x. What we're looking for. We're going to add that to our anion. We have one of those times by its charge, which is -2. And we're going to set it equal to 0. All right, so there's our equation. Clear your parentheses. So we get x minus 2 equals 0. When we solve for x, what does x equal? 2. So it's a simple algebraic equation that we have here, all right, to help us get it. It'll get us the right answer every single time. So our charge on manganese is 2. So what are we going to call or name our compound? Manganese 2. Then what? Oxide. Manganese 2 oxide. And again, what does that Roman numeral tell us? The charge. It does not tell us subscripts. It tells us the charge. All right? It tells us the charge. Let's go ahead and do the next one together as well. All right? Fe3PO4 2. Where am I going to draw my line to split my compound up? After the Fe. Now, is it going to be right after Fe or is it going to be after the 3? Yeah, after that 3. So Fe is my cation. How many do I have? 3. I don't know its charge, so it's x. Now, how many anions do I have here? 2. And how do we know that? Because it's on the outside of the parentheses, guys. The inside is what I call a package deal. It stays together. It's not going to change. The formula of your polyatomic on the inside will never change. The outside number tells us how many we have. So we've got 2. What's the charge on phosphate? You should know it. It's a -3. So our equation here is going to be a little bit more challenging, but still it's not too bad. We've done harder things this year in this class. So we're going to take it 3 times x plus 2 times -3 equals 0. Clear your parentheses, so 3x minus 6 equals 0. How do I solve for this? Add 6, all right. So I get 3x equals 6. X equals what? 2. So what's the name of this compound going to be? Iron 2 phosphate. Iron 2 phosphate. All right, I want you guys to try the next one. Where am I going to split my compound? After SN. Right, after tin. How many cations do I have? 1. Charge is X. We're going to solve for that. How many anions do I have? 2. All right, and then what's the charge on oxygen? -2. So here we go. We're going to take 1 times X plus 2 times a -2 equals 0. So X minus 4 equals 0. X equals 4. So the name of this would be tin 4 oxide. What's that? Tin 4. That's funny. Look at that. I didn't even catch that. Tin 4. Tin 4. This is awkward. All right. Guys, there's one more I want to do together. And then, after we do that one together, I will tell you what your homework is going to be. You guys will have a chance to work on it and ask any questions you may have. I'll walk around and can help you out. And I'll be grading your quizzes if you don't have any questions. So, the next one I want to do, guys, is this one, MnSO4. We're going to do this one together. First step is to do what? Separate. Where am I going to separate it? Where's my line going to go? Yeah, right there, after Mn, after manganese. How many cations do I have? 1. Its charge is X. We're looking for it. How many anions do I have? 4, 5, 1. I hear 3 different numbers. So let's think about this. All right, I hear a lot of people that are adamant with 5. All right. We said that line, what is that line doing for us? Separating the cation and the anion. So everything before it is your cation, and then everything after it is your anion. If you have more than one element there, guys, what do you actually have? A polyatomic ion. There's no parentheses already here. What do you need to do? Write them in there, guys. SO4 is a polyatomic ion. So when we put the parentheses, this is why it's so important. Okay? How many polyatomics do we actually have? We only have 1 anion here. All right? Without the parentheses, it's just SO4, and you fall into that trap thinking, oh, I've got 4 anions there. Well, if you said you had 4 anions, I'd be like, oh, what's the charge of that anion? You might think, oh, it's -2, right? Because it's oxygen. But guys, that S is part of it. The polyatomic ion is a package deal. Everything inside there stays the same. The formula doesn't change. So even if we see it sometimes without parentheses, you need to write them in there. Get in that habit. It's going to save you a lot of difficulties and hardships later on in the year if you get in that habit now. You got to trust me on that. So what's the charge on sulfate? -2. That's one you had to know for today. So now when we solve for this, I get x minus 2 equals 0. What does x equal? 2. So our name of this compound would be what? Manganese 2 sulfate. All right, it's a lot different than manganese 8 sulfur oxide. I don't know, whatever you would call it there before, guys. You've got to get in the habit. This is why I had you guys memorize certain polyatomics, because they will be common, which is why you want to have your polyatomic list out to look at as you're going through this. But guys, the line, that's the purpose of the line that we draw in there. Excuse me. Everything before it is your cation. Everything after it is a single anion. Parentheses. Now, the subscripts can tell you have multiple of those, but if there's more than one element listed there, it's a polyatomic ion. Get in the habit of recognizing that now. It's going to make your life a whole lot easier down the road. All right. So, any questions before I give you guys time to go? Tyler. Do this one together. SB205. All right. If you guys feel confident, you can continue working on this. All right. SB205. First thing we got to do is what, Tyler? Yeah, put the line. Where's our line going to go? Not after S. Yeah, after SB. Right? Because again, second capital letter is what we're looking for. So SB, that's antimony. How many cations do I have? 2. We don't know its charge, so it's X. How many anions do I have? 5. What's the charge on oxygen? -2. So this one's a little bit more challenging of an equation that we got to solve for, but we can do it. We get 2x minus 10, right? So we have 2 times x plus 5 times a -2 equals 0. So this is going to be equal to 0. What's the first thing I got to do to get x by itself? Add 10. So we get 2x equals 10. What is x going to equal?
5.
So the name of this compound would be what? Antimony 5 oxide. Absolutely. Riley just asked, why is it oxide and not oxate? All right? ATE and ITE. What do those endings go with? Polyatomics, guys, the ones that ternary. Ate and I are only for polyatomic. When it's oxygen by itself, that's a type 3 ion where we change to IDE. It's oxide when it's by itself. So if you see an element, guys, and it's 1 by itself, it means it's on the periodic table as a single element. We follow our naming rules of the monatomic ions. Monatomic meaning 1. If it's more than one element and it's got oxygen in it, that's when we use ite and ate. But again, if you have polyatomics, you can look on your polyatomic list. You don't have to memorize all of them, just those 7 that we needed. All right? So, your homework, what you're going to have the rest of class to work on, guys, you're going to finish this worksheet. Your problem set is due tonight at midnight. Then, page 4 in your packet, you are doing the evens. I will be checking for the evens. If you get that done in class, guys, go back and finish the chart from yesterday. All right? That's what you're working on. Raise your hand if you have questions and come around and assist you.